Krol. I'm a software development engineer at Capital One. And maybe to start with, one of the Scrum Masters I really value told me that managing expectation is key. So managing the expectations, I don't have any fancy cuts gifs, so just saying up front. Autolayout, revolution, evolution. I feel like it's not a coincidence that in English language those two words are quite close, and revolutions were always triggered by people unhappy with something, wanted to change, and evolution is like adaptation to those changes by any living entity, let's say. But without further ado, let's move on. So up to iOS 4, Big Bang 2010, just out of curiosity, who started before iOS 4 developing? All right, chapeau guys. Yeah, so devices. I will not be focusing too much on the devices, but just once mentioning, I feel like a bit of a sentiment to iPods, remembering testing the apps on iPods because they were like the weakest devices, so everything was smooth there, was smooth anywhere else. Yeah, so up to iOS 4, life was quite simple. Points were equals to pixels, and to support iPads, we were usually creating zip files with the underscore iPad and defining a different layout for iPad. Everything was simple as that. And we were dealing with auto-resizing mask. I feel like auto-resizing masks are a bit like undervalued still. Well, we're auto-resizing masks. So basically, setting frames, we could define 4 things that could change, like left margin, top, width, and height. So by using those 4 and combining them, basically we could define how the view could be resized if any change of the view or bounds was applied. Funny enough is auto-resizing mask, they has the option of none, which should do nothing, but actually that's not true. If you define something as none, it's actually left margin fixed, top margin fixed, and fixed width and fixed height. So that none option is not really non-option. And there was 2 important methods, size to fit and size that fits. One is calling the other size to fit. Usually we shouldn't override. Size that fits was giving the right frame for the target that we wanted. Yeah. How we were dealing with the rotations. The 2 things I remember was listening to the device orientation did change, and then the method did rotate from interface orientation, and then we were applying something. Funny enough, people were implementing those methods, but in most cases, just dealing with the auto-resizing mask was more than enough. But then iOS 4 came into play. So who started with iOS 4? Anyone? Everyone started before or after, okay. So Apple released Retina screen, so we had scale of 2, better experience. So pixels were not equal to points anymore, and scale property was added to the screen. It wasn't maybe crucial, but I know some designers that were really into like 1 pixel might be 1 pixel on that device, not 2 pixels. And in iOS 4, I don't remember anything more exciting happening. And then iOS 5 came into play, and 2 more devices added, new screen sizes. So things are starting to get a little bit more complicated. Anyone started with iOS 5? Okay, 1. Right. So help was coming, and the big help was introducing the storyboard. Unfortunately, people were a bit skeptic about UI storyboard, especially working with the teams, because touching it was a bit problematic under like any system versioning, because there was a lot of conflict. So at that time, storyboard was there, but big teams were not rather using it. And then there was addition. Vue did layout subviews, Vue will layout subviews, and layout subviews was before, but the changes happened in iOS 5.1, but about layout subviews we'll talk a bit more later on. So Vue will layout subviews and did layout subviews was like a good opportunity for us to deal with any kind of change in the bounds, applying changes for the rotation, so there was no more need for dealing with the notification for the rotation, so it was a bit neater, let's say. And then iOS 6 is coming into play, and that's where the game is changing a lot. Still, a Vue device is more added, a bit as we see, there is a big variety of screen sizes. So yeah, that was a game changer because the Autolayout was introduced. So basically, everything has changed since then. We could say that auto-resizings were good, but they had two problems, really. One of the main problem with the auto-resizing mask was we could manage ourselves in regards to the super view, but not in the content. And additionally, there was a problem with managing between two views with auto-resizing mask. It was more about, I will describe myself, and that's it. It might be fine, and still we could use it, but there is a certain limitation. So Apple had to come with something better, and that was when the Autolayout came. And I think it's quite important at the moment to mention the layout process, because I feel like it's a bit of a troublesome, and looking at the Stack Overflow, there's a lot of always, have you used this method, call this, and it will work. So, but actually it's quite simple. There are 3 steps in how the system is layouting. There are 3 steps. First one is updating constraints. Second one is layouting things. And third is display. We'll not talk too much about the display, because unless someone wants to do something very special with drawing, we could forget about that phase. But we'll focus on the updating constraints and layouting things. So the best place in terms of performance to do anything with the constraints is update constraints. But don't take it as a recipe, so I will do now everything in update constraints because it's the most performant way. No, actually, it's not the way to go. The only way why we should be doing something in update constraints is there is small changes that we want to apply, not like doing everything in update constraints. So it's not about layouting everything there. And why it's more performant, because we could do everything in one batch. So instead of, let's say, on the action of the button, we do something, then if someone, let's say, touch the slider, we do something, it might be more performant to do everything in update constraints, because then we could take on board everything that happened meanwhile, because those methods will be called a lot. So, not many things should be happening there. And yeah, and in terms of layout subviews, I mentioned it a little bit before, but without saying much. So before iOS 5.1, there was nothing happening in the layout subviews implementation. It was just empty. And now, what is happening? Basically, the Autolayout engine is giving the frames. So at the point of layout subviews, we really already have frames calculated. So it's really crucial to call super in your implementation of the layout subviews, because if you would override it but not call that method, then it really means that you're opting out from Autolayout. So there's no point setting constraints, not call layout subviews super. But with overriding those methods, we need to be truly careful, because we can do really great stuff about it, but at the same time, we can cause a lot of problems. Here I will mention remove constraints, add constraints, and a little bit about the layout constraints class itself. So initially, we were creating constraints and adding them to the view, and it was up to us to which view we'll add it, which is fine, but sometimes we could do it in not an efficient way. What I mean by not efficient way is, I can have a quite big structure of the views, and I can add everything to the root. It will work, but it's better to have the constraints as close to the common parent as it's possible. So that way, no one was really protecting us against doing something wrong and nasty. So I prepared a small example here. As you can see, I don't have great graphical skills, but yeah. So the way to create constraints, there was basically 3 ways to create it. One was a visual format language, base and core API, and of course, interface builder. Everything that we could do in the interface builder could be done programmatically, but unfortunately not the other way around. So there were things that could be only done programmatically. In here, I'll only show and focus on a few things here. It should be visible. If not, I'll read it. So personally, I was feeling that the visual format language is is a great tool because you can create a very complex set of layout constraints in just one go. In one line, you can put everything vertically and align it to the left or to the right, as well as defining what should be the size of each element. So it was quite neat. The thing that I would like to point out here is in the first set of constraints, I'm saying direction leading to trailing. And there's also to leading and trailing. The reason why we should always go with the trailing and leading is we need to remember about the internationalization. So if we will have a language from the left to the right, that's why we want to use leading and trailing. Most likely, I cannot think really about why we should go with the left and right. It seems that it's always wrong or not ideal. The visual format language was creating a set of constraints, and then we had a base, like a core API that was just creating one single constraint, which was, the API, as you can see, is quite long and not really readable, but that was the time. And what was happening? If we would define a view and with a key that wasn't existing, then we would have a crash. So unfortunately, things like that could be only found in the runtime. Now we could mention something about the element's characteristics. So there is a method called intrinsic content size that is defining what is the natural size of the element, but there is a small caveat. We shouldn't be using that as a replacement for a width and height for the element. It's not meant to be used in that way. It's more about defining something that couldn't be achieved with the constraint. Maybe there is something like custom drawing that we will be doing, and it requires more calculations. Some elements are using it provided by Apple, like UI slider. It has that. Labels, they have their intrinsic content size. Yep. And two things to mention, content hugging and resistance. Hugging is all about how much or how I don't want to grow, and resistance is how much I don't want to be compressed. And they create two constraints per dimension. Why two constraints? Because priorities. Maybe I don't want to grow, but maybe I don't care if I'll be shrinked or vice versa. This is why we create two constraints, which you can see here. By default, it's 250 for hugging and 750 for the compression resistance. So we can grow, but we don't want to be shrinked. And one thing to mention here is, if you ever create your custom component, it's up to you to call invalidate intrinsic content size if something is changing with the view that could impact the size of the element. There's like a method that it's probably not used. Personally, I have never used it, but the only reason why you might want to use it is I have the set of constraints, but let's say I'm allowing some kind of like a range of sizes from minimum to the maximum, and maybe I want to measure something, and based on that, maybe I would tweak my constraints. So this is the only reason why you could use that method, really. So if there was something happening with the layout, as you can see here, ambiguous layout, that's not good, right? Because if the layout is ambiguous, it's not something that our end user probably would be bothered, most likely would not be even aware. But the problem why we don't like to have ambiguous layout is it might be differently resolved on different devices and on different systems of the versions of the system. So we should really avoid ambiguous layout. It's acceptable to have it as like a transition state. Let's say we are doing something and for a moment our layout is ambiguous. It's all right, but we should end in a situation where there is no ambiguity. Some people are even writing unit tests checking that there is ambiguous layout. I guess it's up to the team to decide if they want to have a unit test for that or not. But yeah, some people are using it. And the cool method is exercise ambiguity in layout. You can basically, on the debugger, check what would be the different solution for that ambiguity. It's more rather for realizing that that might be a problem and how that would affect. Yeah, and another thing I will mention here is constraints affecting layout for axis. We can basically ask if there is any problem, we can ask, okay, I don't understand why there is ambiguity, or I don't understand by what that view is affected. So let's check the constraints affecting the axis, X or Y, and then it's much easier to see what is happening. All right, iOS 7. Again, view more devices. And the big things for iOS 7 is dynamic type. I feel like it was another game changer and a big influence for why we need Autolayout. Because most people would think, okay, it's all about devices, different screen sizes, different rotations, but there's also such a thing like dynamic type, which is all about setting the font size. At that time, if we would use a system font size, and we would change in our accessibility font size, then our app should really respect that, and that was causing problems. Few things to mention here: how we would react to this. We would have to add and listen to the notification. Content category did change notification, and then we would be notified. Okay, someone has changed something, so probably we should reapply our fonts. And here, edges for extended layout. It was all about how we want to react if our view controller is presented with the navigation top bar, which margins should go below, which shouldn't. Yeah, and unsatisfiable constraints. I didn't say much about this before. When unsatisfiable constraints happen, they only happen for the constraints that have the priority 1000, which means we require them. And unsatisfiability happens when basically we say two opposite things, and system is, oh, I don't know what you want from me. And unsatisfiable constraints are really bad, and we should never allow this, because system is telling us, I don't know how to satisfy you. Most likely it will resolve it in a way that probably will like it, but we have never, it's not guaranteed that with the next iOS release, the solution will be exactly the same. So, as we see, it's not really readable what is happening here. The only clue is it's always good to, because it's quite simple view, so there's not many constraints that they are happening and they are like conflicting. But imagine like there is much longer console log. We should look at the bottom because it's telling us why, what is not possible to satisfy and what I need to break, and most likely that's the root problem. So what they've added in iOS 7, they added identifier, and NS prefix was reserved. So they added the possibility for us to define, okay, I will name the constraint. That's it. So if something is happening, we could have some kind of a debug information. My example is not the best in saying constraint 1 and 4 and something. Apple is recommending using name actually of our variable. So if we would say, I don't know, top button height, we should rather say that the identifier to the same name, because then it's really useful. iOS 8, more devices, of course. And another game changers, size classes and trait collections. So why do we really need the size classes? Autolayout was not, on its own, it's not sufficient. Apple was saying in 2016 that there is more than 300 combinations of, if we would consider devices, rotation, split views. So more than 300 is impossible to manage it. It's impossible to test it manually, automatically. No way. So they created size classes, and there are two size classes, compact and regular. And I really like the explanation that they gave how we could think about it. So regular, we could think about if something has a regular width or height, it basically means feel free. It's so big, you don't have any constraints really. Whereas compressed means, compact, it means, there is some limitation, so you should rather go with different layout and think about it. So we have, if there is two size classes, then we have 4 combinations. In the interface builder, it's going to 9 because there is also any. But what is really important, 4 is still a lot, I would say. So it's hard to maintain. But from 300, we can actually go to 2. Why? Because usually things on iOS, they will scroll. So we don't really care about horizontal. Vertical. We only care about the horizontal if something is compact or regular. So the reasons why those source classes are important, we get from more than 300 to just 2 things that we need to really care. And they are provided by the trait collections. And trait collection is the way to think about it. It's basically this description of the environment that our app is running, the state. Another big change that happened, bounds became interface-oriented. So if someone was relying on the bounds, that there is a certain width, certain height, then there was a lot of tweaks to happen. There was a lot of changes in terms of rotation. The whole rotation API just get deprecated because what was expected from us was expected to deal with size classes and trait collections changes. Another important improvements, finally, there was a good support for self-sizing cells. The only thing we had to do was just say there will be automatic row height. We estimate that it's going to be around this, just for the performance reasons, and then just give us full description of the content of the cell, and then we'll do everything for you. And adaptive margins, that's another big thing that happened. Layout margins and preserved superview layout margins. I'll just mention it here, but we'll get back to this in a second. Another change. I mentioned before that adding and removing constraints was a bit tricky, or at least not the most efficient way to do it. And the reason was the parent. So now what happened? There is activation and deactivation. And activate and deactivate is not happening anymore on the view. It's happening on this layout constraint class. And the massive improvement for us is we don't care to what is the parent or what is the common parent for our tree of views. System will do it for us, and we'll apply it to the closest parent. So that's the why, because Apple is saying activation, deactivation is more performant. So one reason is it's applied to the right parent, and secondly, we are not removing anything from the array of constraints and re-adding it, which is also associated with some cost. We are just activating. It will be there, but it will not be taken into the constraint solver. So it's just more performant that way. Things to mention, they are not necessarily related with Autolayout per se, but they are very close. So we used to say present something modally or push. Now we can say show, and we don't care about the container. The system will resolve it for us. So we will not say push or present modally. Depending on the structure of our view controllers, system will do the right action for us. Change that happened was in the landscape. The navigation bar started becoming a bit smaller, so we have bigger space for the content. So anything, when we were hard coding any size like 44 plus 20, it became a bit obsolete and troublesome. And finally, split view controller became available on devices. iOS 9. So probably many of us are still supporting it. And the big changes that happen here. So Apple added a new class, and it's layout anchor. And anchor is another nice improvement. I basically rewrote the example that I had before, just to use anchors. I'm not saying that's the way to do it. It's way too many constraints here, and they're not really readable. But I just wanted to show that at least they're a bit more succinct. And the good thing about anchor is, if we write something that doesn't make sense, it might be resolved on the compile time rather than the runtime. So we get a quicker feedback loop if it would be, let's say, assigning things that doesn't make sense. We'll get the compile error. And I mentioned a little bit before a layout guide. So why this is great? They created a class because Autolayout is resolved with a Kosovari constraint resolver, which has a super linear complexity, which basically means that we'll be fine to some point. Let's say if we cross 200 views in a view controller, then there might be a performance hit on how they will be resolved. It's going to be fine to some extent. So what I mean by this, we were using a lot of like a spacer views that just were helping us making sure that the views will resize. Let's say we wanted to have a fixed size elements, but the space should be flexible. So we were adding a UI view that was not visible, but it was used as a spacer. And it's all right, but there's a problem with UI view. It has a layer, and the layer is a bit heavy for that task. So adding a view that is not necessary and it's not visible seems like a bit of an overkill. So layout guides, it's basically the rectangle. It's just inherits from NS object. It's just the rectangle that only contains information about the space, but doesn't contain the layer. So it's lightweight. So if we just wanted to resize something and have a spacer, we could create a layout guide. And two that are by default provided with the UI view are layout margins and readable content. What is the difference? So layout margin is some offset from the edges that is mostly used for, let's say, it's like a default space. Usually in the visual format language, we were using just that dash, which by the way is called aqua space. And now there is a layout margin for this. And readable content guide is used when we are containing label with the text. So it's dynamic because, for example, for a big iPad, we just want to have a bigger spaces from the sides just to keep it more better, more visible. And on a small device, that will also shrink. Another big thing that happened is UIStackView. So before, when we wanted to lay out something either horizontally or vertically, we had to write those long constraints either using a base API or visual format language. But now we have a stack view. Another great thing about it is it's managing, let's say we have a case that we were adding more elements depending on some rules horizontally. Before, we could do it with a visual format language saying, okay, if you add another view, then please apply this constraint saying width will change, etc., etc. Right now, we have stack view that is doing it for us. And the great thing about stack view is not just, let's say, taking from us the heavy lifting, but it's also more performant. The reason why it's more performant, it's having the NS transition transform class that is basically managing all those kind of things. And the most beautiful thing about stack view is, let's say, something has happened. We rotated or iPad, we used the split. So we are getting called a traits collection did change. So applying those changes is simple as that. But there is no magic behind, so constraints are still getting created. One thing to mention here, it wasn't introduced with iOS 9, it was probably long before, but we can nicely, let's say, list all the views that are currently visible in our key window. And the nice thing here is it's showing when there is ambiguity, as well as which one are built with the Autolayout and which are built manually. There's a small caveat to this. If you want to run this on the Swift code base, you need to add this expression -l object ++ o. Otherwise, it won't work with Swift-only code base. iOS 10, more devices and more scales, even scale 3. But the really big thing, I would say, there's another game changer is preferred content size category on the trait collection. And what is that? So remember I said before that responding to the font size changes, we had to have notification, observe the notification, apply the changes, which was a bit troublesome because, yeah, adding it to each view controller or doing it with some base class, it's quite inconvenient, requiring a lot of work. But now, we already have the implementation for trait collections did change. So now there is another property added. And I listed the view values here, which are like category M, XL, and there is 5 accessibility sizes. And then they have just the prefix accessibility just to avoid XXXXXXL. this is a really cool thing. Let's say we have our app. It looks good on a default size. But what will happen if someone has some kind of a vision problem? That person most likely will have a different default font size. And unfortunately, if you would just take a look on your apps that you're using on a daily basis and change the font size, and even being very nice to the app, and you would kill it, giving it the chance to rebuild everything from scratch, I can assure you that most of the apps is not doing it. So if you have any vision problems, your app will not really respect that problem. And according to Apple, 1 out of 7 people worldwide have some kind of disability. It might be vision loss, it might be hearing problems. So it's really important to start thinking about it, especially that right now it's so easy. So the thing I wanted to show here is with the accessibility inspector from iOS 10, instead of just changing the settings on the iOS app, in the iOS settings, going back and forth, which is troublesome, you can just open on a desktop. You can just open Accessibility Inspector, change the device that you're targeting from your desktop to the simulator, and just play a bit with the slider, and it will resize automatically. It will apply it. So as you can see here, I haven't done anything, so my top left label is pretty much not visible. So that's a problem. So that tool is really great to help us discover problems with our auto-layouting. And things that I didn't mention before talking about the layout subviews. I just said that we need to be super careful about overriding this method. And same applies really for updating constraints and set needs display layout. Because what can happen? If we do something wrong, we can end up with a layout feedback loop, which is problematic, and how it will be observed. Let's see, probably the most common scenario would be you have a button, you're clicking the button, and you are expected to go to the new flow. Something should show up, but it's not showing. And and we just see that, let's say the CPU is 99% usage, memory is just growing, and at some point there is a crash. And there is a big log, what happened? And that log is not really readable, so it's a nasty thing. So Apple has a way to help us with this, and it's called, so basically we can pass a launch argument with a threshold that will be from, I think, 50 to 1,000, which basically means how many times the layout is called, layouting subviews is happening in one layout pass. And those layout passes are happening a lot. So if in one go we are calling it 50 times, there's a lot of things happening. iOS 11, finally. Big change now is save area. Things that became deprecated is top layout margin and bottom layout margin. Before we were just using it to stick our constraints. Let's say my label should be 20 points from the top. And we were sticking it to the top layout margin, but there was a problem with it, how we should react if there is navigation. iPhone 10 came to light, which has completely different size of the navigation bar, and if there is incoming call, the navigation bar is not changing for that device. On the devices we have that green, the green stripe, but not on iOS, not iPhone 10. So we have a save area layout guide now, which is basically telling us, all right, this is the area that will be visible and it's safe to put any elements in the save area. Another reason why they also brought it in is iPhone 10 the screen is to the very edges, and there are also corners. So it's quite crucial not to stick anything to like margin, because it might be clipped. And if it's like a crucial button for us, it will not be visible or it will be cut, so it's not good. So we have a safe layout guide, and for auto layout is this. For a manual layout, we have insets. And the great thing about it is, even if you apply it, now you will see it in an interface builder. It's there. If you select it in, I think, first tab, it will be there. And the great thing about it is it's backward deployable. So you don't have to worry, oh, I will use it now, but I'm still supporting iOS 10 or iOS 9. So maybe I should wait with this or add some other abilities. No, you don't have to. basically they've done the hard work for us, so it's backward compatible. Another change was to the stack views. Before, in the example before, I was using a certain amount for spaces, but now they've added a spacing use default and spacing use system. So the good thing is that we don't have a magical number anymore, and there will be one more thing that I will mention in a second why it's nice. Yeah, and some additions to Anchor to make it even more verbose, including the spacing after, all sorts of things. And this is another great class, UI font metric. So before, I think, iOS 10, if we would like to scale our fonts, it wasn't supporting custom fonts. Now we can support custom fonts for the, I mentioned these font categories that then they are getting resized. Now we can do it with our custom fonts, thanks to UI font metrics. But it's even cooler than just fonts. If we had any sort of, let's say, margin between elements, and let's say it was 15 points, with this class now, we can resize that value according to the font size that we have chosen. Because it might make sense for us to have just 15 points on when the font is quite small. But that 15 points might not be enough if the font is, let's say, taking half the screen. Maybe the space between to make it readable should be bigger. So with the UI font metrics, we can also scale any arbitrary value, which is pretty cool. Another nice thing is, because it's all about thinking about people with some sort of disabilities. So if we allow people to have to change the font size because they might not see it, why we should only apply it to the font? Sometimes our app might present the images that they are also carrying a value itself. If it's some sort of a background, then yeah, probably it's not as important. But if that's some sort of graphic that is crucial for, let's say, conveying a message. Let's say it's a plus button with a big plus. It doesn't have a text, but that plus is a message that we want to send. So why we are scaling font but not the image? Thankfully, now we have the way to do it. And in the interface builder, you can just set adjust image size. So the image will be also scaled with changes to the accessibility settings, which is, I would say, brilliant. And for the keen reader, I would just mention that there are two things, content layout guide and adjusted content insets. If you feel free to read more about this. I mentioned before ambiguity. When ambiguity is happening. So there is a rule of thumb that for any view to be layout, we need to have at least two constraints. One would be when is the x and the size, or y and the size, right? Two per axis. But still, so if we don't have this, then we'll most certainly will have ambiguity. Because, okay, let's say I said that my offset should be 20 points, but I don't have the second constraint that is defining what is the width. So that means that my width can be half screen, how could be the whole screen, which means there is ambiguity. So they've added this nice exclamation mark in the interface builder. So if you see it, it's something that you should, that should drag basically your attention that something is going wrong here. We should change it. So let's get to the summary. So we need to forget about device-specific thinking. So there is no more like, oh, for iPad or for iPhone. We should even stop thinking about iPhone Plus size, iPhone 10. We shouldn't be thinking about devices at all because most certainly Apple will add more devices with another different screen sizes. So it's just going to be a pain for us in the future. We have our new friend size classes we should really rely on. Fixed height for the elements is most certainly it's going to be an issue. As I said, people with the vision problems, they will have a different font size and things will be clipped, will be cut, so they will not be readable. So to that fact, they will not be really enjoying the experience on our app if things are just overlapping. So we should always think about how our layout will look like with the bigger fonts. So we should put everything probably to like scroll views, let the elements grow. This is why fixed height is most likely a better idea. We should avoid ambiguity. Ambiguity could be just as a transition. We are changing some constraints, so the ambiguity can be tolerated for some time. Fix unsatisfiable constraints, and think as like a tip. When you are changing constraints, it's always good to first either remove or deactivate constraints before adding or activating new constraints. The reason why is unsatisfiability will be reported immediately, and the layout will, oh, I don't know what to do. So we could have some sort of like transition issues. I added a constraint, so immediately something happened and it looks bad. And really, please, please, please test your app with the accessibility settings. Change the font size. Give some time to your testers or product owners app with the increased font size. Let them, test it for you. I know that there is always a discussion with the designer, like, yeah, but it looks nasty when I increase the font size. Yeah, it might not look beautifully, but it will be usable, and we won't make our apps usable. They don't always need to be beautiful. My tip would be discussing with the designer, like saying, yeah, but it looks nasty, I don't want it. And why we do it is just, a small percentage of our custom base. So yeah, if it's just a small percentage and it looks nasty, so why do you care that it will look a bit, let's say, different? Let us do it the right thing. General tips. I based my whole session watching just WWDC sessions. There is a couple really good sessions starting from 2012 that will be still relevant up to today when they are talking about introducing Autolayout. Then review often used class APIs, because we are ending up on a most likely Stack Overflow, and people are just saying, oh, call layout if needed, call settings display, it worked for me. Some people say, oh, it didn't work for me. It's just, it's not about the guess game. There is no magic behind the scene. If you know what you are calling, there is a full description about it, then you will understand why it's not working, why it's a bit wobbling. So, and I'm finding like a lot of developers, they're just relying on blog posts and Stack Overflow and just copy-pasting without really understanding what's happening. So really read the documentation. That link is really nice in terms of new iOS releases, because it's just telling you the crucial bits, what has changed, with a very short description. So it's a really nice way to keep up to date quickly. There's probably like in half an hour you will get the whole view, what has changed in iOS, what I should read more and spend time more on. And references. I know there's like eyes are crying, but those are the sessions I watched preparing to the talk, and some of them, they are also mentioning like accessibility things. So, because for me, Autolayout is not only layouting things per se, setting up constraints, but it's also about accessibility, adaptivity. So there is a bit of more topics going into this. The talks that I can definitely recommend is from 2015, session 218 and 19 is Mastering Autolayout. That's definitely worth watching. And if that wouldn't enough, there is more. There is two good sessions from 2017 about mastering adaptivity, or from 2016? Yeah, 2016, sorry. 222 and 233. And in terms of designing, there are two at the bottom, two links at the bottom. But the good thing is they're very short. So do you have any questions? Everyone is sleeping.